A lot of people assume it must be really difficult to set up a 3D vision system for picking up parts using a robot for things like depalletizing or bin picking. Let me show you how quick and easy we can set up a part using Mech-Mind Vision software. So we've got these 3D printed conrods, multicolored because they look pretty. We're going to start in Mech-Eye Viewer. This is where we configure the camera. So I just click on this button and I take an image. You can already see that I've got quite a nice looking image there. I can look at my depth map. This is changing the color of the pixels based on the height. And then I can look at my point cloud where I can actually rotate this round and see the image I'm getting. Now, one thing I need to bear in mind is that I'm going to stack some of these parts up. So I need to check that I set up all of my 3D settings, my ROI and things like that. So I not only get a nice looking image, but I've got enough of a region of interest that I can pick up my parts. So let's set up the ROI first. Actually, that's pretty good. I'm just going to move that about a little and I'm going to apply that. The 3D parameters, I could set those myself, but I can also just click auto set. When I do that, it says, where do you want me to concentrate? So I'm just going to leave that region there. And I'm going to click on calculate exposure time. Now it's taking multiple images, alternating that light to work out what's the best settings to get a nice point cloud. Now that it's done that, I can look at the point cloud, I can spin that around and go, yep, I'm not losing any features there. I can also do things like bring some more parts in, stack them up a bit. And we can calculate that exposure time as well, just to make sure that it's okay when we're looking at things that are higher up. There we go, nice point cloud there. So I'm happy with that, I'm going to apply that. The 2D image, I can set that up as well. I can use a completely different exposure value or different settings for the 2D versus the 3D image. In what we're doing, we're not really using the 2D image, it's just something pretty for us to look at. But I just want to make sure that I've got a good looking image here. At the moment, I've got it on auto exposure, so it's going to change the exposure to try and get this target grayscale value of 90. And you know what, that's a really good looking image, so I'm going to leave that alone. Let's just trigger that again. Now I've got them stacked up. Yep, they're looking good. If I put that there, maybe put one at an angle. How's that looking? Looks good to me. I can then save that off as a set of values. So I've already got a parameter group here called Conrod. And now I've done that, I'm finished with Mech-Eye Viewer. I can now come over to Mech Vision. So this is where we're actually going to train it what the part looks like and get it to find it. So I'm going to do a new solution. I'm starting with a blank solution here. As you can see, the software is fairly simply laid out. We've got all of our tools down the left-hand side here in what we call our step library. We've got some debug outputs. We can get data and images over on the right-hand side. Let's jump straight in though. We're going to drag and drop, capture images from camera. I can turn on the debug output here. I need to tell it what camera I'm connecting to. So it's a Mech-Eye camera. I select the camera from my list. And I've now linked that to my project. Okay, yes, confirm that. And I can click run. Now I've got my image coming in from my camera, as you can see there. Next step is we want to find our part. So we're going to do recognition, 3D target object recognition. I need a couple of inputs coming in here. So I just simply drag and drop those. So I've got my color and my depth map coming in there. I can turn on my debug, I can run that. It gives me a warning that I've not configured a part, and that's fine, but I can look, there's my depth map, there's my color image coming in. So now I can configure my 3D target object. To do that, I'm going to use my target object editor. When that opens up, I'm going to select this first option. I've got a 3D model of this part. I've got it saved in an STL format. I'm going to call this Conrod, and I'm going to go and find it. It is on my desktop in a folder called Conrod, and there it is. Open that, click OK. It's going to import that into my software, and then it's going to ask me to choose what sides am I interested in. Now, I could get it to find all of them. If I'm expecting to find that part standing up like that, I want to train in that face as well. I could train in that face. So I could leave all of these ticked if I want to. I don't have to if it's a fairly flat part and it's always going to be sitting pretty much with one face visible. I can just use that face. But for now, I'm just going to leave that with all those views ticked. And I'm going to change it to millimeters rather than meters. I'm going to click next. It's going to have a look at it and it's worked out the shape of my part. I can spin that around like that and I can see it. So now it's got the center point of my part. I can then click next and I can go and set up a pick point for it. So I can click add to create a pick point. Now I'm going to drag this pick point here and I'm going to move it over so it's around the center of the big bore on my conrod. Now I happen to know that that's about 32 mil. So I'm going to set that there. I'm also going to move that in the Y direction 7.5 millimeters because I know my part is 15 mil thick. And as you can see, that's then brought that up to level with this flat face here. The other thing I want to do is I want to make it so my Z is pointing upwards. So we tend to have the part, the Z's pointing upwards, our tool on our robot, the Z is pointing downwards. So they work together. To do that, I can, just to make sure I'm going the right way, I can move that around and you can see that we're spinning it around X and I'm at minus 81. So I'm just going to change that to minus 90. I know it's a 90-degree move. And once I've done that, I've got my pick point now. I'm then going to add another one. The reason I'm going to add a second one is because this part, the camera doesn't know if it's up this way or if it's up that way. So what we're going to do is if it says, actually, no, I found it that way up, my pick point is on the bottom facing down into the table. That's no good. So we train it 2 pick points in opposite directions. So I'm going to click add on that and it's going to create me another pick point. I'm going to do the same movements that I did before. So on my X, I'm going to move by 32 mil. On my Y, I'm going to move by 7.5. Of course, it's minus 7.5 this time. And that has put us down the bottom. And I need to spin it around as well so that my, oh, wrong way, that way. So my Z is pointing downwards. Just going to change that to 90 degrees because I know it's nice and straight. Now I've got my X's, my red arrows here are going in the same direction. And my blue arrows, my Z's, are in opposing directions. That's exactly what I want. Not interested in green, doesn't matter to me. But that means that when I pick it, it's always orientated the same as far as the conrod's concerned in its direction. I can then click next and I can do save. Okay, it says just give me a moment while I save that off. Save's complete. I am back in my 3D target object editor. Now I can click on Config Wizard and it brings this up and it gives me this image here. I'm going to set my region of interest. Now everything's upside down because my robot is up the top as far as it's concerned. Obviously, once we'd calibrated this with the robot, it would actually change to where the robot really is. I'm going to give myself a little bit of movement now. So I've got a bit of height. But other than that, that looks pretty good. Give that a bit more space there. Save and apply that. I'm going to run this step. In fact, I'm going to run the whole project. Gets me a new image. So there we go. Next. So I've got my conrod has been loaded in here. And you can see that we've found all of these parts. It's showing me the center location rather than my pick points at this step. It also gives me a quality that we're getting here for both surface matching and 3D edge matching as well. You can see these are all up in the sort of high 80s, 90%. So just to get rid of anything that's no good, I'm just going to set that at 0.7, which is 70%. I can run that step. So we're getting rid of that one down the bottom where we've only got a bit of a match. I'm going to click next. I'm going to click save. That's been saved. I can now run again. And as we can see, we've got this color image. Each part has got a different color to it, and it's finding all of these parts that it's found. Notice that the red X arrows are all sticking out in line with the conrod. And you can see that we've got our Z's going up and our Z's going down. We've got 2 pick points for all of those. Now, we don't really want to give out all of those pick points to a robot because we don't want it to try and pick from under the table. So what I'm going to do is I'm going to filter out all the ones that are pointing downwards. To do that, I'm going to come to my next step here, which is pose processing. I'm going to do my adjust pose, give it my pick points. I'm going to run it. I'm going to hit config wizard. It's going to open this up, spin this round so I can see it. At the moment it's doing an auto alignment, which is, I don't want it to do that. So I'm going to tell it don't do that. So now it's giving me Z's going up and down. We're not going to transform the poses at all at this point. We're going to go to next. And what I'm going to do is I'm going to filter my poses. I'm going to filter them by angle. And what I'm looking at is, I'm looking at the Z axis in the robot frame, and I'm going to change it from positive Z to negative Z. And now I've got all of these points here facing up. And I'm going to say save. I'm going to run that job. Turn on my debug output, sorry for that tool. And there we have it. 3D recognition of our parts. As I take that top one off, run it again, you can see that we're now finding the yellow one in the middle, that one there. Take that off. And there we go. Let's stick one at an angle just to make it a bit more interesting. And you can see that that's tilted my pose that it will give out to the robot so that it's tilted in the direction of the part. It's that simple.